thanks everybody for coming. I'm going to talk today about kind of where we are at in terms of the state of the art today in data science, and also make some comments about what I think that means for our organizations and where things are going to be heading over the next few years. So I've been involved in and around analytics for about 20 years now. I was McKinsey & Company's first analytical specialist 20 years ago. I founded A.T. Kearney's global customer analytics practice. I guess that was about 16 or 17 years ago. And I've had 3 companies kind of in and around the data space, although Kaggle, the company I'm at now, is the first totally focused on machine learning, which is really where my heart lies, I must say. I also teach data science at Singularity University, just down in Mountain View. Just to get it out of the way, the company I'm at is Kaggle, not Kaggle. In Australia, those vowel sounds are more distinctive than they are here. So. Okay, so let's talk about what we do with data. It concerns me that often at conferences, we hear a lot about how to store data. We learn about how to query data. It's kind of how do we scale up our data processing infrastructure to store more stuff or to query more stuff or to query faster. But I actually want to point out that when it comes to actually getting competitive advantage out of your data, it's actually all about increasing the degree of intelligence of the way that you analyze it. This is not a framework that I came up with. This is where this comes from 2007. And so everything underneath the dark line here is kind of business as usual. So we've got the classic standard reports from 30 years ago. I guess 10 to 20 years ago, we started to see business intelligence become all the rage. We had kind of OLAP, pivot tables, Cognos, business objects, so forth. And then 10 years ago, maybe even 15 years ago, we started to move towards proactive alerting. So things like dashboards was all the big craze then, I guess. But really, all this stuff kind of under the line there is just telling you what's happening. In fact, you actually have to say, I'm interested in knowing what's happening. Now you just add that up for me or tell me when that thing crosses that threshold. So really everything under that dark line is reactive, not proactive. So as we then want to get to kind of true competitive advantage, you have to get much more intelligent ways of using data. So the stuff above the line here, which in particular I want to talk today about predictive modeling and optimization. Predictive modeling is where most of the state of the art is going on right now, although there are some places that we're starting to see optimization take over. So predictive modeling tells you what's going to happen next. It's not, you don't have to say, here's something that I think might be happening, is it happening or isn't, or why is it happening? It just tells you what's going to happen next. Optimization does even more. It says, this is what you should do about it. So that's the kind of the overall framework of actually getting value out of this money that you're investing in Hadoop or in HANA or whatever. It's about what do you do with it. So what can you do if you're really leveraging data effectively? And so to answer this question, I'm actually going to draw from my friends Andy and Eric's book. I don't know if you guys have read this book. Probably a lot of you has. It was #1 on Amazon quite recently, Race Against the Machine. This was based on many years of research at MIT Sloan, looking at what does it mean kind of socially and in terms of employment and so forth, of the fact that computers are now doing many things that used to be the domain of people only. I bring this up because in particular, Andy and Eric came up with 4 specific examples of things which not only are computers doing that used to be the domain of people only, but which just a few years ago, nobody believed computers could ever do. So I want to give you these 4 examples right now. things that until very recently nobody believed computers could ever do, and yet they're doing them today. The first, this is Andy and Eric, the authors, standing in front of the first example. That is the Google self-driving car. There are many research papers, articles, and so forth until very few years ago explaining why it would be impossible for a computer to ever drive a car. And I can assure you, I've been in that car. It drives safer than any human that I've ever been with. The second example they gave was translation. This is a French poem. This is a professional human translation. This is from the free service translate.google.com. It's not quite as good. Mind you, this was the 3 years ago version. This is from the New York Times. But it's not bad at all. And literally, I remember I studied a little bit of linguistics at university. There was a pretty strong consensus at that time that computers would never be able to translate human writing. That was in the days that we talked a lot about the Chomskyan, Noam Chomsky universal grammar. We were a long way away from understanding what that grammar was, and we felt it would be years and years of human expertise, linguistic analysis to deeply understand this universal grammar well enough that we could build a vaguely effective machine translation tool. And yet now here is one freely available. The third example, I'm going to put this up here for a moment. This is from Forbes. It's the start of an article about an Apple earnings report. Can anybody tell me anything that they see odd, unusual, curious about this piece of prose? I can't see anything much either, except that the byline here, who is narrative science? Narrative science is a computer algorithm that writes newspaper articles to a quality that they appear in Forbes. I don't know if this says something about Forbes or about machine learning. I'll leave it you decide. But nonetheless, this is something that people purchase. Actually, another friend of mine has a company that he has a computer algorithm that writes newspaper articles about sports results. So with things like this and the sports results version, you just feed it the data about the earnings report or the sports result, and it creates a pretty readable story. In that sports case, it's actually become very useful in kind of the long tail of like smaller leagues or less successful sports or so forth. And so there's a lot of kind of smaller magazine articles and so forth that come out of that software. So popular are those articles that actually it won a journalism award from one of the sports conferences, and so they rang up the guy and said, could you send one of your reporters out to talk to our conference? And he had to explain they didn't have any reporters. So here's an example again. Just a few years ago, nobody believed that a machine could write prose to a quality that we would be interested in reading. And then the fourth example you're all, I'm sure, familiar with. Right? Winning Jeopardy. This is something which we really did not believe would be possible just a few years ago. To win Jeopardy, not only do you have to understand all those nuances of human language, but also it's full of subtle word plays and all kinds of things designed to throw off both humans and machines. And yet, Watson not only won Jeopardy, but easily beat the two greatest players ever to have played the game. Why do I bring up these four examples? Well, what is the common theme amongst these four examples other than the fact that they are examples of technologies which we did not believe were possible just a few years ago? They are all the direct product of machine learning. So all of these are just predictive models. So if you go back, for example, and think about translate.google.com. So I spent time learning about Noam Chomsky's work on universal grammars and trying to understand how kind of the underlying theory of grammar works and so on and so forth. And then Peter Norvig at Google came along and he said, I don't know, about all this business. All I'm going to go and do is I'm going to go and mine the web for examples of documents that have been written in 2 different languages, and it's the same document. And then I'm going to run a machine learning algorithm on them and see if basically the predictive model says given document A in English, what do you think document B in Spanish would be? And that is all translate.google.com is. It is nothing but a predictive model that predicts what a document would look like in target language B given a language A document. And that was built using nothing but finding the correlations between those parallel texts online. So, interestingly, when it comes to the crunch, in this case and many other cases, the machine learning approach, which is just give the data to a computer and see what comes out, is far more effective than anything that human experts were ever able to create. A similar thing with the Google self-driving car, just a big box full of predictive models. And really the same thing with Watson. Watson doesn't really understand anything about human language or anything about human knowledge. You can see that when sometimes it says really, really stupid things. But in the end, the predictive models that we've built by feeding it the right kind of data and algorithms are more powerful than any human mind. So we're now at a point where we can do things we didn't think were possible before. The other thing I want to point out is we're also now at a point where we can do things more quickly and cheaply than ever before. And I wanted to give an example of something that might almost seem trivial compared to those. So this is something called Detectify. Anybody here who has done a technical degree will know how annoying it is when you have to type up your equations. There's always one symbol, you've forgotten the name of it, right? And if you don't know the name of the symbol, you can't put it in the computer, right? And I would hate to think how many countless hours people have wasted on this stupid little problem. One PhD student said, right, I am never going to have that problem again. So what he did was he grabbed the manual for TeX, which is the typesetting program that creates those formulas, and fed in all of the names of the symbols and the shapes of all of the symbols. And he then created a machine learning program that would predict if you drew a symbol, what is it closest to in terms of those shapes, and it would tell you the name of the symbol. So here's an example where I did a really crappy job of drawing sigma, and it told me, okay, \sigma is the name that you need. I mention this because this one kid, PhD student, did this in one day. And since that time, it's been used over 2 million times, right? So think about now how easy it is. This is with free open source software on a laptop computer. You can create stuff that millions of people use. So data science today can do things we didn't think were possible before, but also we can do things more quickly and easily than before. So that's kind of where we're at now. I also wanted to talk a bit about where we're going and what it might mean for our organizations. So I believe, let me just get a show of hands. How many people here are in I guess, startup-sized companies? Okay, and how many folks here are in kind of larger and more established corporations? That's great, that's what I understood. So I'm going to talk about some implications for both folks in startups and in more established corporations. The punchline will be, if you're an established corporation, you should be terrified. And if you're in a startup, you should be very excited. So, having said the punchline, let me take you there and see if you agree with me by the end of it. This is a front page New York Times article from November last year. And picking apart this article and understanding why it was a front page New York Times article tells you a hell of a lot that you need to know about why I just said what I said. So that is what I'm going to do. This is what the article said in short. That is a hell of a lot of very domain-specific language and deep knowledge to pick this apart. So what I'm going to go and do is I'm going to go through and explain what is deep learning, what are machine learning competitions, Chemo Informatics, feature engineering, domain-specific knowledge, speech recognition, general machine learning in 12 minutes so that then you can understand what the hell I'm talking about. So let's go. By the end of all this, I think you'll understand why this breakthrough tells us a hell of a lot about what the next 5 to 10 years of both machine learning and more general organizations are going to look like. And so let's start with machine learning competition. So this front page New York Times article described a new algorithm that had just won a machine learning competition. What is a machine learning competition? Well, it so happens I actually ran this project, and my company does nothing but run machine learning competitions, so I am well placed to explain to you this piece of the story. This is my company's homepage. As you can see, there are a number of competitions. They have varying different lengths of time, varying different prize money, ranging from $3 million, $100,000, and some which are $5,000 to $10,000. Folks come to this site in order to compete in competitions to try and predict better than the next guy some kind of outcome. So, for example, in this case, it was predict better than the next guy for GE when flights are going to land and when they will get to the gate. So we had something like 300,000 flights, and we basically gave people data where they'd been cut off in midair, and we said, when will they land? This example here, the Heritage Health Prize, is predict which of these insurance customers are going to end up in hospital. So basically, if you can predict something better than the next guy, you win the $3 million. Why do we run machine learning competitions? It seems like a quirky thing. Well, the reason why is it's almost outside of professional sports. It's almost a uniquely suitable place to run true meritocratic competitions. So if I play tennis, you'll know whether you're better at tennis than me because you'll whack the ball past me or you won't. Right? If we play golf, you'll hit less strokes or you won't. Most areas of kind of business or science, we can't think of it that way. But predictive modeling is different, and I'll show you why. I'll give you an example. So here's a table, for example, of products. So you might have a table of products with return rates and information about what that product is and what category it's in and what market it was being sold in, so on and so forth. So in real life, there would be maybe 100 columns and maybe 1 million rows. It would obviously be very useful to you if you could predict for a new product in a new marketplace, what will the return rate be? You could make all kinds of useful strategic decisions based on that information. So, how would you go ahead and build a predictive model? This is the best practice approach to doing that and has been for the last 20 years, and therefore almost nobody ever does it this way. So what you do is you grab your data, you scramble it, kind of randomly reorder it, and then you grab 2/3 or so, and that's what you get to keep. And the other third, you lock it away. Ideally, somebody else does all that, so you don't even ever see that other third. You then analyze the 2/3 that you got, and you try to build your model, in this case, say, of return rates. Now, you need to now find out how good that model is. So what you now do is you get access to these green cells. In other words, you get access to the other third, but not the actual thing you're trying to predict, right? And then I challenge you to tell me what those question marks are. So you'll give me a column of numbers. Right? So this is kind of pretty standard best practice in predictive modeling, has been for a long time. Now, if you think about it, this is a recipe for a very fair contest, right? Because if I asked all of you to give me your column of numbers, I can just see who was most accurate, right? That's all a machine learning competition is. And so at its heart, what Kaggle does is every time you upload a data set, we just do that. Right? And if you go to any Kaggle competition, you can see you can download a training set, you can download the test set, you can then upload your guess as to that column of numbers. We then compare it, and then in real time, you appear on a leaderboard, and you can find out exactly where you're placed, what your score is, and you can put in multiple entries over time based on that feedback, trying to improve. Okay? So we've run hundreds of these things. So you can now start to understand why it's somewhat interesting that somebody won a machine learning competition. It means they're the best in the world at something. Not New York Times worthy yet, but we're starting to get a hint of why that's interesting. And there's been lots of pretty big results come out of machine learning competitions in the past couple of years. For example, one of the other projects I ran last year was for the Hewlett Foundation, which was we grabbed tens of thousands of handwritten essays from 11 states in the US. And this is an example. of one of the questions that they were given for those essays. And what the states gave us, as well as the handwritten responses, was 2 teachers had marked them. So we got the marks for each one. And so what we did was we said to our community, can you come up with an algorithm that would score, that would grade the answers to those essay questions? And can you come up with an algorithm that is the same as what the teachers would have given anyway? And like, we literally didn't know if that was possible or not. You know, I started this by saying this is kind of like, can data science do that? We didn't know if data science can do that. There were examples of algorithms people had written in the past, but they were not, you know, they were not as accurate as the human teachers were. So we didn't know what would happen if we took that out to a competition. It turned out that the answer was yes, they could, and that got a huge amount of reaction in the worldwide media. It turns out that the winning algorithms out of this competition are more consistent with the human graders, the human teachers, than the teachers were with each other. Right? So, speaking to teachers, they tell me one of the reasons for this is they just don't have enough time to grade essays. Right? But for whatever the reason is, the fact is, based on teachers in their current situation, machines can grade them more consistently with humans than humans can with each other. And this is an example of the kind of amazing results that come out of these machine learning competitions. In fact, every one of the 300 projects we've done, every single one has surpassed all previous scientific and industrial benchmarks, just like this one did. So, winning a machine learning competition is interesting of itself. This was particularly interesting in this case because they used something called deep learning, which previously had been used for specialist areas like speech recognition. Now, it really has been a cutting-edge tool in speech recognition in particular. Right? I don't know if I haven't got time to show you the video today, but Google for Rick Rashid Mandarin translation and check out this video. Particularly check out the last third or so, where you will see the head of Microsoft Research speaking in English while in real time a computer translates his voice to Mandarin in his own voice. So the way they did this was using this technology called deep learning. So for a couple of years now we've known deep learning can do some amazing things, although it's been in some specific niche areas. So what is deep learning? Deep learning is basically an extension of this. This is something from 1995. A guy named Jan LeCun, actually in response to a competition, so there were competitions even back then, by the US Postal Service. And the competition was to come up with something that can read handwritten zip codes. And it turned out that this thing called a convolutional neural network actually could read handwritten postcodes as accurately as a human can. And so, in fact, this system has been reading your zip codes on envelopes since 1995. This is what the US Postal Service uses. You can see that behind the scenes, it's creating a whole bunch of features, you know, like top and bottom edges and outsides and so forth. But what was really interesting about this is that this convolutional neural network was not specifically written to find those features. It finds the features automatically. Right? And so in the last 15 years or so, what's happened is that technology has been extended to find features automatically in other types of data, such as audio data, which is now used in speech recognition. Right? And if you know a bit about machine learning, you'll recognize that the idea of finding features automatically is very, very interesting. So the question is, can we do that more generally? So one example is Chemo Informatics. So this particular project was a Chemo Informatics project. What's Chemo Informatics? Chemo Informatics is one of the world's most exciting businesses that you've never heard of. Every big pharma company in the world uses this. It's automatic drug discovery. You analyze, using machine learning, data about molecules and automatically predict which ones will be toxic, which ones will be water soluble, so forth. It's worth billions of dollars. So we ran a competition for Merck to see if people could come up with better chemoinformatics algorithms. So hundreds of man-years, thousands of man-years of effort had already been thrown at this problem. And this was the result of the competition. This is time. This is accuracy. Change of color represents a change of leader. Right at the very end, 2 weeks to go, someone came along and beat everybody else. Somebody came along and found a better Chemo Informatics algorithm than has ever been created before. How did they do that? Well, it turns out that the people who did it know nothing about molecules, know nothing about chemistry, know nothing about Chemo Informatics. In fact, they only decided to enter with 2 weeks to go. They grabbed their deep learning algorithm and tried to use it for general purpose machine learning. They automatically generated features from the data. This was what Geoffrey Hinton's group did. And you'll now get a sense of why this is New York Times worthy. The world's best Chemo Informatics algorithm was built automatically in 2 weeks. This was an interview with me that occurred about 2 weeks later. And you can probably see where I'm going with this. It turns out that computers can translate human speech better than ever before, knowing nothing about linguistics. Machines can predict the structure of molecules better than anybody before, knowing nothing at all about the structure of molecules. In general, computers are able to see past all of our assumptions, and they can look at just the data. And so the empirical results now are that when it comes to these kinds of areas, machines learning from data are doing a better job than human experts are. For example, this is our top-ranked competitor. He knows nothing about the used car market, yet he won a competition and is the world's best at creating algorithms to predict which used cars will be returned to auction. He has the second best algorithm in the world for credit scoring, predicting who will default on their loans. The second best in the world for churn prediction, which is predicting who's going to be lost as a customer to a retail organization. This is the Merck Prize. He was actually the second to Geoffrey Hinton in the Chemo Informatics competition. He was the fourth in the world in the automated essay grading competition. So this is an example. People like Xavier, the world's best data scientists, can use general purpose automated tools to be the best in the world or amongst the best in the world at a huge range of different areas. And what's really interesting is they do this using small data sets. Every single Kaggle competition I'm aware of has been won using a laptop computer running free open source software. Right? So creating these best-in-class algorithms is not about creating huge clusters and doing kind of mass big data. Every laptop now has billions of bytes of storage on it, often in solid-state disks. Right? And free open source software is actually now the best in the world when it comes to things like the best statistical libraries. It used to be that we thought that the larger data sets you created, the more accurate your models would be. This is a 2001 study that showed exactly that. It turns out that is only true of very specific areas such as natural language processing, i.e. trying to understand the richness of human language. This is what it normally looks like. This is the Netflix recommendation system. As you add more recommendations to it, pretty quickly the power of the algorithm actually tails off. This actually comes directly from the Netflix engineer responsible for that algorithm. Right? So to summarize here then, really what I'm trying to say is that we are moving from human expertise to data. This is the bit that's terrifying for the big corporates in the room, because it means that the stuff that you used to use your proprietary expertise to maintain competitive advantage, the startup sitting next to you, they have the data and the laptop computers and the open source software to do better. Right? But they're not just going to use data. It's actually about how you use it using these kinds of sophisticated algorithms. And these algorithms are not like Chomsky and universal grammar algorithms where we human experts build them, but they get automatically generated through machine learning. So that to me is the state of the art of where we are right now. And I think that impacts everybody in this room, regardless of whether you're a startup or a corporate trying to hang on to your competitive advantage. Thank you.